7 gigabytes. That's what you have left. 7 gigabytes on a drive that should have had hundreds. And right now, somewhere in the background, Windows is quietly taking more. You've seen the warning, that little red bar under your C drive. You've probably already tried the obvious things. Emptied the recycle bin, deleted some old downloads, maybe even ran one of those cleaner apps that promises to boost your PC. And yet the number barely moved. If anything, you might have noticed it's somehow getting worse. That's not a coincidence. That's by design. Here's what nobody tells you. Windows is not a passive operating system sitting quietly on your hardware. It is an active, restless system that is constantly writing files, reserving space, caching data, and hoarding gigabytes you will never see unless you know exactly where to look. And the tools most people use to fight back, the disk cleanup utilities, the one-click optimizers, they're only scratching the surface. They clean the visible mess while the real damage happens in the basement. What you're about to discover isn't a tutorial. It's closer to an investigation, because what Windows is doing to your storage goes deeper than most users ever realize. By the time this is over, you won't just have your gigabytes back. You'll understand exactly how they were taken, and how to make sure it doesn't happen again. Let's start with the warning itself, because it's lying to you. When Windows flashes that low disk space alert, most people assume it means they're actually running out of space. But here's what's really happening. Windows triggers that warning at a threshold. Not when your drive is physically full, when it crosses a percentage boundary that the system arbitrarily decided is dangerous. And the moment that warning fires, Windows starts doing things in the background to protect itself. It begins compressing files. It starts throttling certain processes. It earmarks additional storage for emergency use. The very act of warning you about low space causes Windows to consume more space. You're watching it panic, and its panic costs you gigabytes. But that's just the surface layer. Underneath it, there are files on your system right now that you never created, never asked for, and never knew existed. Files that Windows generated silently in the background the moment you turned on your machine the first time. Files it has been adding to ever since. Some of them are honest about their purpose, most are not. And collectively, they could be eating anywhere from 8 to 40 gigabytes of your drive. On a machine running low, that's the difference between functional and frozen. The first hidden offender is called hiberfil.sys. Most people will never even see it. It lives on your C drive, flagged as a protected system file, invisible by default. You would have to specifically change your folder settings to even acknowledge its existence. And yet on most systems, it's between 4 and 16 gigabytes in size, sitting there, doing almost nothing. Hibernation is a Windows feature designed for laptops. When you close the lid and walk away, instead of sitting in sleep mode and slowly draining the battery, Windows dumps everything from your RAM directly onto the drive, into this file, then shuts down completely. When you open the lid, it reads it all back, and you're exactly where you left off. The size of hiberfil.sys is directly tied to how much RAM you have. 16 gigabytes of RAM? You have up to 16 gigabytes of hidden files sitting permanently on your drive, waiting for a hibernation event that, on a desktop, will never come. Most people have this enabled and have no idea. Windows never asks permission before creating it. It just appears. And if you don't use hibernation, if you shut your machine down normally, or your system is a desktop that's always plugged in, the file is pure recoverable waste. To eliminate it, you bypass the GUI entirely. Open a command prompt with administrator privileges, then type powercfg or hoff. That's it. One command. Windows will immediately delete hiberfil.sys. On a 16 gigabyte RAM system, you just reclaimed 16 gigabytes in under 2 seconds. No third-party tool, no scan, no risk. Just a command the system already knows that most users never learn exists. The drive breathes a little, but we're just getting started. Now let's talk about ghost storage. This one is more recent, and in some ways more insidious, because Microsoft added it intentionally and explained it in technical documentation so dense that almost nobody read it. It's called reserved storage. Windows 10 and 11 automatically set aside between 4 and 7 gigabytes of your drive space. Not for your files, not for your programs. For future Windows updates. The logic, from Microsoft's side, is actually reasonable. Updates fail when there's not enough free space to stage the new files. So rather than let updates fail, Windows pre-carves out a dedicated chunk of your drive and holds it, not occupied, not usable, just reserved. It shows up in your disk usage as used, but it contains nothing you can access. On a machine with 400 gigabytes free, this is mildly annoying. On a machine with 7 gigabytes left, it's catastrophic. You are fighting over leftover crumbs, while Windows has locked away a private reserve it won't touch for itself and won't give back to you. To reclaim it, open a command prompt or PowerShell with administrator access and type dism online set reserved storage state disabled. This tells Windows to release the reservation. The space doesn't disappear, it becomes available. The catch is that the next major Windows update may re-enable it. This is a battle you may need to fight again after significant updates. But right now, in a crisis of space, this is legitimate territory you can reclaim. By now, you might be wondering, why doesn't disk cleanup catch any of this? Because disk cleanup was designed to clean the files that users create. Temporary internet files, old thumbnails, recycle bin contents. It was built in the late 1990s, updated occasionally, and it fundamentally does not touch the system's own hidden infrastructure. It's a janitor with a broom, and you need something closer to a surgeon. The things disk cleanup consistently misses include the Windows Update cache, a folder called Software Distribution that stores every update package Windows downloads, even after the update is already installed. Think about that. Windows downloads an update file, installs it, and then keeps the original download sitting on your drive indefinitely. Not because it needs it, just because it never cleaned it up. On a machine that has been running for a few years, the software distribution folder can grow to 5, 10, even 20 gigabytes. It fills silently with files the system has already finished using that it will probably never touch again, and disk cleanup won't remove them. To clear it yourself, you need to stop the Windows Update service first. Otherwise, it will protest when you try to delete its files. In an administrator command prompt, run netstop wowserv. Then navigate to C, Windows Software Distribution. Download and delete everything inside. Not the folder, just its contents. Then restart the service. Net start wowservo. Windows will rebuild what it actually needs the next time an update runs. Everything you deleted was already consumed. It was storage equivalent of keeping every Amazon box that was ever delivered to your house, because you didn't realize you could throw them away. Deep underneath that, there is something called the WinSxS folder. Its name stands for Windows Side by Side, and it is perhaps the most misunderstood folder on the entire operating system. It lives at C, Windows WinSxS, and if you check its size, you might see something between 8 and 30 gigabytes. Sometimes larger. It looks enormous. And most guides will tell you to leave it completely alone. Here's the nuance they don't explain. WinSxS contains multiple versions of system components, DLL files, drivers, libraries, kept simultaneously so that different programs can each use the specific version they were built for. It's why one program from 2018 and another from 2023 can both run side by side without conflicts. The folder is genuinely critical. You cannot simply delete it. But here's what Microsoft doesn't broadcast. A significant portion of what WinSxS contains is what's called superseded components. Old versions of system files that were replaced by a Windows update. They still sit there, just in case Windows needs to uninstall that update and roll back. After a certain period, the system marks them as safe to remove, and it will remove them, but only if you explicitly ask it to. In an administrator command prompt, run diasm-online cleanup image, start component cleanup, reset base. The reset base flag is the important part. It tells Windows to remove the fallback versions of every installed update, permanently committing to the current state of the system. You lose the ability to roll back old updates. On a machine that's been running stably for months, that's a trade most people should take. In exchange, you might recover 2 to 10 gigabytes of space that the system was silently hoarding as insurance you never asked for. Now we enter stranger territory. Because beyond updates and hibernation, Windows has a second life running in the background that most users have never directly confronted. It's the telemetry and diagnostics layer, and it generates its own private archive of files that grow continuously over time. Every time an application crashes, Windows generates a diagnostic report. Every time a driver behaves unexpectedly, a trace log is written. Every time the system's health monitoring runs, which is constantly, entries are added to an event log. These aren't small files individually, but they accumulate. The event viewer archives alone can grow to several gigabytes on an older machine. Diagnostic traces stored under C program data, Microsoft Yellow Diagnosis, can fill hundreds of megabytes. The Windows error reporting folder holds compressed dumps of every crash your system has ever had. The system calls these temporary, but some survive for years without being cleaned. ETL files, event trace log files, are scattered through multiple system directories. They record low-level diagnostics about hardware performance, network behavior, and system events. They're not accessible through normal file browsers without changing permissions. They're generated by components you never consciously launched, collecting data about your machine's behavior continuously. To clean the event log, you can open Event Viewer, right-click on each log category and select Clear Log. For the diagnostic data under Program Data, you'll need to manually navigate there with administrator access and clear the contents. For ETL files scattered through the system, a scheduled task that runs the disk cleanup utility with the Sage set and Sage run flags can help, but manual review will always catch more. The registry itself accumulates references to these logs, old diagnostic paths, pointers to files that no longer exist, telemetry service configurations that have left artifacts behind. While aggressive registry cleaning can cause problems, targeted removal of broken references using the registry editor with care and a backup in place can reduce both file system noise and the system's inclination to create more of it. There's another layer that almost nobody thinks about until they see the numbers: AppData. Every application you install on Windows gets a sandbox inside your user profile. The AppData folder lives at C users, your name JAPData, and it has 3 subfolders: local, localo, and roaming. Inside these, programs store their caches, their settings, their temporary files, and their logs. Most well-behaved applications clean up after themselves when you uninstall them. Most don't. What remains is the ghost of every program you've ever tried, deleted, and moved on from, a game launcher you used for 2 months, a photo editor you installed once for a project, a video call application from a company that no longer exists. Their folders remain, their caches remain, the databases they built to track your preferences and recent files remain. On a machine that's been used for a few years, AppData can quietly accumulate 10, 20, 30 gigabytes of orphaned data, folder names you don't recognize from programs you don't remember installing, browser caches that were never purged, game platform data from accounts you abandoned. To investigate, navigate to AppData Local and sort by size. You'll immediately see which abandoned programs have left the biggest footprints. Folders belonging to uninstalled applications are safe to remove. Browser cache folders, Chrome's stored under AppData Local in Google where Chrome user data's default cache, can be cleared manually or through the browser's own settings. The difference between what disk cleanup will remove and what actually lives in AppData is significant. The system calls it your data. But much of it is data about you that you never asked programs to keep, generated by processes you were never told were running, stored in a location most people never navigate to. And then there's the page file. When your machine runs out of physical RAM, Windows doesn't crash. It carves out a section of your hard drive to use as overflow memory. Slower, but functional. This is called the page file, and by default, Windows manages it automatically, which sounds helpful. Until you realize that automatically usually means set to a size equal to or larger than your total RAM, and expand it whenever the system feels like it. On a machine with 16 gigabytes of RAM and a system-managed page file, you might find 4 to 8 gigabytes locked away for virtual memory, space that Windows has claimed from your C drive and will not release without direct instruction. To control this, open System Properties, navigate to Advanced, then Performance Settings, then the Advanced tab, and click Change under Virtual Memory. Uncheck Automatically Manage. From here, you can set a fixed minimum and maximum, which prevents the file from expanding during periods of high memory use and never shrinking back. You can also redirect it entirely. If your machine has a second drive, moving the page file there frees the C drive from that obligation completely. Even on a single drive system, setting a fixed, smaller size can reclaim gigabytes that Windows otherwise holds open-ended. The trade-off is real. If your machine hits memory-intensive workloads and the page file is too small, performance will suffer. But for most users on most machines, the default is dramatically oversized, finding a middle ground that reflects your actual workload, rather than Microsoft's worst-case estimate, is legitimate optimization, not risk. At this point, you may be thinking about reinstalling Windows, or buying a new drive. Both are valid options. But before you do either, there is one more concept to understand, because it determines whether the space you've reclaimed stays reclaimed. Windows has a built-in behavior that treats free space as an invitation. The delivery optimization service, for example, will use free space on your drive to cache Windows update packages for other machines on your network. If you're on a home network, your PC might be quietly storing update files intended for other devices. You can disable this under Settings, Windows Update, Advanced Options, Delivery Optimization. Superfetch and Prefetch are services that analyze your usage patterns and preload data into storage, so programs launch faster. On a machine with plenty of space, this is a reasonable trade. On a machine critically low on storage, it's adding fuel to a fire. Prefetch data lives at C, or Windows prefetch, and can be cleared, though Windows will rebuild it based on your habits. System restore points consume storage proportional to how aggressively you've configured them. Each restore point is a snapshot of your system state. Multiple restore points means multiple snapshots, which can add up to several gigabytes. Reducing the number of retained restore points, or temporarily disabling them on the C drive, while space is critical, frees that territory. And Windows Update itself, the very mechanism meant to keep your system healthy, will continue staging new update files into software distribution as long as it's running. Periodic manual clearing of that folder after confirming updates have installed is a maintenance step that pays consistent dividends. Here's what it looks like now after all of this. The hiberfil.sys is gone. The reserved storage is released. The software distribution folder is cleared. The WinSxS fallback components are compressed and pruned. The diagnostic logs have been cleared. The AppData relics from deleted programs have been removed. The page file is fixed at a rational size. The delivery optimization cache is off. You didn't install anything. You didn't buy anything. You didn't run a scanner that promised miracles and delivered ads. You went in. You found the files. You understood what they were. And you removed them through the same tools Windows uses to manage itself. The number on your C drive has changed significantly. And the reason it changed isn't magic. It's that you finally saw what Windows was doing while your back was turned. The thing that nobody tells you when you first get a Windows machine is that the operating system has its own agenda. It reserves space for updates you haven't downloaded yet. It logs activity you never asked it to monitor. It keeps old versions of system files as insurance you never requested. It lets applications write to your drive without telling you, and it surfaces none of this through the ordinary interface most people ever interact with. The low disk space warning feels like an emergency, and it is, just not the kind Windows implies. The real emergency is that a system you own, running on hardware you paid for, has been quietly allocating resources for its own purposes, without a menu option or a dialog box asking your permission. What you did today was refuse to accept that arrangement. You went past the warning, past the cleanup wizard, past the third-party tools that add their own footprint to a machine already struggling to breathe. You opened a command prompt and told the system directly what to do. You deleted what Windows wouldn't delete for you. You disabled what Windows would never disable on its own. You took the storage back. This is your machine. It runs on your electricity, on your desk, doing your work. The operating system serves you, not the other way around. And now, for the first time in a long time, it's starting to act like it. The drive isn't suffocating anymore, but check it again in a few weeks, because Windows remembers its habits, and so should you.